Welcome back, students. I hope you all are doing great. All right, so last class we had stopped at understanding the computational thinking and the components of computational thinking. Today we will learn about decomposition. Decomposition is the process of breaking down complex problems into smaller and easily manageable parts. These smaller problems are solved one after another until the bigger complex problem is solved. In this stage, it involves breaking down a problem into smaller components so that the smaller components can be tackled easily. The more we break down a problem, the easier it is to solve. Some real life examples will be when we taste an unfamiliar dish and we identify several ingredients just based on the flavor. We are decomposing that dish into its individual ingredients. When we give someone directions to our house, we are decomposing the process of getting from one place to another by breaking them down into smaller, simpler tasks. When we break a course project into several steps, we are decomposing the task into smaller but more manageable subtasks. Like in the math question that you saw, you can decompose a number. Okay, so if you have an equation or you have a quadratic equation, on the first look, when we look at a quadratic equation, it appears to be very scary and difficult. But then we learn to decompose it, breaking it down, remember? And then we can solve it very easily. When we note down the steps to solve a problem, we often recognize patterns. And by giving a list of steps, we are one step closer to creating an algorithm. The stage decomposition allows us to develop a better understanding of the problem by identifying all the components in detail. So in this stage, you look at all the components of a problem in more detail. Pattern recognition is the next process. It helps in identifying patterns or trends within a problem. Once we have completed decomposing a complex problem into smaller problems, the next step is to look at similarities that they share. We look for patterns when we play games to decide when to do certain things. Based on experience, we develop shortcuts or mapping problems characteristics so that we can arrive at a solution. Imagine that we want to draw lots of cats. All cats share common characteristics. They all have eyes and tails and fur. They also like to eat fish, make meow sound. But we all know that all the cats have eyes, tails, and fur, and so we can easily make a good attempt at drawing them by including these common characteristics. In computational thinking, these characteristics that are common are known as patterns. Once we know how to describe one cat, we can easily describe all other cats simply by following the same pattern. The only thing that is different are the specifics. So one cat's eyes can be black, the other cat's eye can be blue. So the specific may change, but the pattern remains the same. If we want to draw a number of cats, finding a pattern to describe cats in general, that all of them have eyes, tails, and fur, makes our task easier and quicker. We experience pattern recognition even in our everyday situations. For example, when you're driving or a driver, he looks for patterns in the traffic to decide whether and when to switch lanes so that he can drive faster. People also look for patterns in the stock prices to decide when to buy and when to sell. Scientists look for pattern in data to derive theories and models. We look for patterns and learn from them to avoid repeating the same mistake. Patterns are shared characteristics that occur in each individual problem. Similarities in small decomposed problems help us solve complex problems more efficiently. Abstraction. Abstraction refers to focusing on important information only, ignoring all the irrelevant details. To reach a solution, we need to ignore unnecessary characteristics and focus only on relevant details. It helps to identify specific similarities and differences between similar problems to work towards a solution. Important information that we need to focus on, what are these? We focus mainly on the general characteristics that are common to every element instead of specific characteristics that are common only to specific elements. Common examples of extraction processes are a world map. A world map is an abstraction of the Earth in terms of longitude and latitude. It helps us to describe the location and geography of any place. A sign of an aisle in a store, example walnut, is an abstraction of the items available in that particular aisle. When we write a book report, we summarize and discuss only the theme or key aspect of the book. This is all called abstraction. Once we have the general characteristic, we can create a model of the problem. A model is the general idea of the problem that we are trying to solve. Once we have a model with us, model solution to the problem, we can now design an algorithm. So up till now, we have broken down a problem into smaller, easily manageable problems. We have identified similarities between those smaller problems. And now we have also focused on the relevant details and ignored all irrelevant. Now it's time to develop a step-by-step instruction to solve each of the small problems. These can also be called as rules to follow when solving the problem. These simple steps or rules are used to program a computer to help a complex problem in the best possible way. And it's also called an algorithm. An algorithm is a plan, a set of step-by-step instructions used to solve a problem. Writing an algorithm requires extensive planning so that the algorithm can work correctly. The solution that the computer offers is as good as the algorithms we write. If the algorithm is not good, then a solution will also not be good. If the algorithm is good, the solution will be perfect. Computational thinking can also be used with other academic subjects, like literature, in which you break down the analysis of a poem into analysis by meter, rhyme, image, structure, tone, diction, and meaning. In economics, when you are finding cycle patterns in the rise and fall in the country's economy. In culinary arts, especially when you're writing the recipe. In mathematics, when you find out the rules of factoring. And in chemistry, determining the rule of chemical bonding and interaction. Programming languages have been created to meet the needs of programmers and individual users. They are efficient tool to develop applications that positively impact the working of an organization, economy, and society by increasing productivity and improving efficiency. Languages, programming languages will die and they become obsolete when they fall short of the expectation of the user. And then they are replaced and superseded by more powerful programming languages. Python is a programming language that has stood the test of time and it has remained relevant across industries and businesses, programmers, and individual users. So, Python programming language. Right now, I'm going to stop my class here. I want to introduce you to program next class. We will talk about Python next class. I would like you all to do a little research and come. It's very interesting to find out why Python language has this name called Python. So you can find out some fun facts on Python that you all can comment on my next video. Okay, so that will be your homework. Takeaway homework will be finding some interesting information on Python that really interested you or that really made you feel wow. Okay, so that will be all. Stay home, stay safe, take care, and keep learning.